Hey there, this is Evan with one last time EB3D printing. This may be my last video as EB3D printing. I am going through a name change here shortly, but I will fill you guys in more with that as the time comes. But for right now, I still am EB3D printing. This is my first video like this. This is going to be a product review video. BigTreeTech reached out to me, asked me if I would be interested in reviewing their SKR3 boards. So they sent me over the SKR3. Unfortunately, they didn't have any easy stepper drivers. They were going to send me the easy board, which I'm pretty excited about trying. I haven't tried any boards with the easy drivers yet, but for right now, I'm just doing the regular SKR3 with the normal pinned stepper drivers. Just to be open, again, they did send me this board for review, but they are not paying for this review. I am a big proponent of BigTreeTech products. Every single one of my printers has them. I have the whole way from the SKR Mini 3 V2. I have the SKR Mini E3 V3, and I have a few BigTreeTech Octopus Pros. With that being said, I'm actually very excited to receive this board because this board will be going into the Ender 5 Plus. That printer currently has the SKR Mini 3 V2 in it, which only has 4 stepper drivers, so you cannot independently control the Z-axis. With this board being a 5 stepper driver board, I can use the extra extruder driver to control the Z-axis independently. So instead of hooking both Z-axis up to the Z-axis stepper driver here, I can actually hook the Z-axis up independently. So I will be walking you through how to do that once we get to the setup portion of this video. But for right now, this part is just going to be a quick, short little unboxing, walk you through some of the pinouts of the board, and just take a little deep dive into, what the board has on it right now. As always, with all my videos, I'm going to have sections, the timestamps in the description below, so you can skip through to parts of the video you want to watch. But for right now, we're just going to do a quick unboxing. All right, so let's move on to unboxing these things. We'll start with the stepper drivers first, just to show you that they are the normal stepper drivers. If we can get this box open. There we are. Take a look inside. We have, as you can see, these are the normal stepper drivers. The pin stepper drivers, they will go in the stepper driver slots. But I just want to pull them out just to show you they are the normal stepper drivers. All right, so let's move on to the star of our show, the SKR3 board. I already took this out previously just to double check, make sure everything was in here. Our duck is a bit of a casualty here. I don't know if I'll be able to get this stretched out. There we are. Duck's good. Duck's good to go. All right. So pull this board out here. This is the SKR3 board. And check this out. So far, it looks good. All the pins are nice. Nice thick PCB here. Moving on, we'll see what else is in the box. Pull this out. We have our USB cable. This is probably going to be my only gripe with this board. Is I wish it was a USB-C or USB, at least micro USB cord. These larger USBs are a bit dated, and I'm going to have to make some modifications to the case, the electronics case on the Ender 5 Plus to get this to work. But that seems to be about my only concern with the board. We have some extra pins here, it looks like. Extra connectors, I should say. So we have, looks like JST XH connectors here. We'll see what we can pull out. Yeah. Oh, and then also the jumpers, motherboard jumpers. We're probably going to need those later on once we dive into setting up the board. Yeah, and these are the pins that go in the connectors. Awesome. I was not expecting to receive those. The one cool thing I noticed with this box is, and I think I think it's also on the Octopus Pro box as well, but they started stamping on the pinout diagrams on the back of the box here. So you don't have to go find Google the SKR3 pinout board. You can just flip the box over and you'll see where the pinouts are. So that's definitely a very convenient feature to have. So you don't have to go digging around trying to find the pinouts. So now that we have the board out of the box, I'm going to go through a quick comparison to see how it stacks up against the previous generations of this board. So looking at the chart here, you can see it has a new processor, the STM32H series, supports 480 megahertz frequency, which is a significant improvement over the previous generation, the SKR2, which was only 168 megahertz. It does allow for 5 amp output, which means you can power a Raspberry Pi from this board. I won't be powering my Raspberry Pi from this board yet because I plan on making an enclosure for the Ender 5 Plus, which I'll be moving all the electronics around anyways. So as of right now, I'll just be using standalone power for the Raspberry Pi. It also, compared to the previous versions, it does support 3 fans like the SKR2 does, but it uses this jumper here to control the voltage between 24, 12, and 5 volts for the CNC fans. It does have the USB PC communication interface. And again, that is probably my only kind of gripe with this board, is it still uses the old USB style interface instead of more updated micro USB or USB-C interface. This is the first SKR board that is native support for Klipper. They already have a config file, basic config file set up. I'll be walking through that in a later part of this video. Another new feature for this board is they have native support for PT1000 thermistors. When I go through the pinouts for you, I'll point out the pinouts for the PT1000 thermistors. So the SKR3 also supports 100K NTC thermistors. Down here we have the typical connectors for them. But new to the SKR3 is PT1000 thermistor supports. I will point out the pins for them once we go through a later part of this video when I walk you through the pinouts. The next new feature for the SKR3 board is a reserved bootloader. This means that it is not impossible, but a little more difficult to brick the control board by flashing bad firmware. You basically press this button here and then it enables device firmware updater mode, and it allows you to flash new firmware to the board. Also new to this board is onboard EEPROM for setting storage, like Marlin and RepRap firmware. You can store the settings to the board. Those features won't necessarily apply to me because I am using Klipper firmware, which most of the settings and stuff are saved onto the Raspberry Pi. So another new feature for the SKR3 board is they switched to these blade style fuses, which are easier to find compared to the micro style fuses they used before. Some other features to touch on for this board is power loss recovery, filament runout sensors. It also supports BL Touch. Even though it doesn't have the universal BL Touch connector, you have to have 2 connectors for the BL Touch. It also supports auto power off and then 5 volt RGB control as well. So that's it for the features and specs of this board. Next up, I'm going to run through the pinout of the board, just give you a brief overview how this is laid out. And so let's jump over to that. So I'm just going to give you a quick little walkthrough of the pinouts on the board. If you want a more thorough walkthrough, I suggest you check out the channel BigTreeTech. He has a very thorough breakdown of this board, and he's a lot more knowledgeable about this stuff than I am. So I definitely highly recommend you check out his channel to get a better understanding of the nuts and bolts of this board here. But starting at the top, we have our basic pins. These two pins right here, these are basically always on fans. So like your hot end fans that are constantly running, you just turn the printer on and they automatically turn on. These do not have any PWM control with them, so there's no option to control the fan speeds or anything like that. It's either on or off. It's as simple as that. Then we move on to our typical stepper pins here. You got the X, Y. You have 2 connectors for Z-axis, and then you have your 2 extruders here on the end as well. Like I said, what I plan on doing is I'm going to use all 5 of the stepper drivers, and then I'm going to connect one Z-axis stepper motor to the Z-axis stepper, and then the second Z-axis stepper motor to the actual second extruder here. I will break down the jumpers here on how you have to set up the jumpers for UART mode once I get into actually setting up the board for Klipper. I'll give you a better understanding of that, but like I said, this is just a quick little walkthrough. Moving down here, we have 3 PWM fan connectors. Now the cool thing that BigTreeTech started doing with the boards, especially with the Octopus Pro, and that I wish they would implement on all of their boards, is actual voltage control jumpers here. So you can actually run a 24 volts, 12 volts, or 5 volt fans here. Unfortunately, with these 3, the jumper controls all 3 fan voltages at the same time instead of individual control. If they could implement individual control onto these smaller boards, like they did on the Octopus Pro, that would be so helpful for all of the printers getting set up. That way you could run, you know, like a 5 volt or 12 volt fan on your extruder hot end, and then 24 volt fans on the parts cooling and stuff. And it would just be super helpful going forward. And that's my one, I guess, piece of info I would like to relay to BigTreeTech is these voltage control jumpers are awesome. If you could find a way to implement them to individual controls for the fan jumpers, that would be awesome. Moving over here to the right side, we have the display connectors. These are your EXP1s, EXP2s. Right beside the display pins, you have your end stop pins. You have your Z, Y, and X. So next to the end stop pins here, we have a pin for power loss recovery. And then we also have 2 pins that enable filament runout sensors. Now, the one thing I want to point out is below these pins, we have the pins for a BL Touch or auto bed leveler. If you run a BL Touch with a single connector, it will not work for this board. You actually have to have a BL Touch that is split up into 2 connectors. Fortunately for me, that's how the Ender 5 Plus is already set up, so I don't have to go around and resplit the wires or, you know, crimp on connectors for the BL Touch to work. So zooming in really quick here, just to look, we have our RGB pin right here for controlling RGBs. But right next to them, we have sets of 2 pins here. These are for the PT1000 thermistor controls. And then right next to that, we have another set of pins. This is for the power supply control to turn on and off the power supply. So zooming back out again, we have the pins for the extruded thermistors, and then we have the pins for the bed thermistor. Right next to that, we have the pins for the TFT display. And then next to that, we have the pins for the CAN control. We have our typical micro SD card slot and our USB slot next to that. Moving up the side here, we have our connectors for the heat bed, the DC in, and then extruder 1 and extruder 2. Now, one little tip that I picked up from Eds3D Tech is to use a Sharpie to mark the positive and negatives. Now, all I do is use the black Sharpie to mark the negatives. So for the heat bed, it is this side. For the DC in, it would be this side. And then for the extruders, it would be the bottom ones back again. So just mark these off. That way it's just easy to tell when you quick hook up the board. That way you don't have to try and read the board while you have it in the printer. Just makes it a lot easier. Just look at the screws here, look at the tightening screws, know which one's positive, which one's negative, and you're good to go. So that was a quick, simple little breakdown of the pinouts on this board. If you want a more thorough, deep dive into the board, like I said, I recommend checking out Eds3D Tech. But for now, the next step for me is to go and actually install it into the Ender 5 Plus, and I'll walk you through how to do that. So before we dive into setting up this board for the stepper drivers, I do want to make one correction. The correction is about the voltage control on the PWM fans. You will actually need a add-on for that, and you'll need to purchase one of these voltage control boards separately. They do not come with the SKR3. They run, I think they're around $10 for this. In order to set up the SKR3 for voltage control, you'll need to plug this jumper board in between these 4-pin connectors here, and then also switch this red jumper here between the VIN to VOT, I think it is, yes, VOT mode, and that'll allow you to switch the fans between 5 volt and 12 volt. If you want to run straight 24 volt, you don't need this on, and you just keep the jumper where it is currently set. So now that that is out of the way, and I made this little correction here, I will go dive into setting up the jumpers for the stepper motors. So now we are ready to set up the jumpers for the stepper motors. I am currently using the TMZ 2209 stepper drivers. So I will go ahead and refer to the manual to see how to set up these jumpers for the stepper drivers. So looking at the manual here, it's pretty straightforward of what we need to do. We need to remove the first, second, and fourth jumper on each one of these stepper drivers to set up these stepper drivers into UART mode for the TMZ 2209 drivers. So I will go ahead and get that done, and we will cut back after I get all the jumpers off. All right, so now that we got all the jumpers off, we can go ahead and put our stepper drivers into the stepper driver slots. These should be pretty straightforward of how to connect them. It's essential of matching color to color. Now, if you are colorblind, it would be quite a bit more difficult. Fortunately, BigTreeTech does supply the stepper driver pinouts, a very easy to read diagram here, and just make sure you match up the signal pins to the correct pins on the board. Another easy way to tell which direction the stepper drivers go is to look here at these end pins. One side only has an L shape to it, and that side matches up with the L shape that's on the board. So that's another quick and easy way to tell which way these stepper drivers go into the board. So with that said, I'm going to put these stepper drivers into the board and then also apply the heat sinks as well. One thing I want to point out real quick are these, you'll notice that they have these little turn screws on top of the stepper drivers here. These are the potentiometers that you would use if you were to set up these stepper drivers in standalone mode. These are essentially the voltage control regulators that are on top of these stepper drivers. You see these a lot of times on the stock Creality boards where their default configuration is the stepper drivers in standalone mode, and then these potentiometers are how you control the voltage for those stepper drivers. So now that we got our stepper drivers in with the heat sinks on, our board is pretty much set up ready to go into the printer. But first, what I plan on doing is reinstalling the display mount. I reprinted it again in ABS and made some modifications so it uses heat set inserts instead of just the M3 bolts into plastic. It should hold up a little bit better being in the enclosure. So that'll be what I install first, and then I'll go on to in-depth installing this board into the Ender 5 Plus. So I got the display mounted as well as the display put in, and now I'm going to focus on removing the SKR Mini E3 V2 board. But first, this is a recommendation I have for everybody that decides they want to try to working on the electronics of their 3D printer, and that is to get yourself a cheap little label maker. This makes it very easy to keep your wires and everything else straight when you're working on the printer. All I do is label each wire basically the same as the board labels, and then put the labels on the wires themselves. That way I can keep track of which wires go into which port on the motherboard. So I'm going to go ahead, get these wires taken off, label them up, and I'll cut back after that is done. So I successfully have all of the wires disconnected and labeled according to which port they were in. Now it's just a matter of putting the new board in and matching up the labels with the correct ports on the new board. Another recommendation I have is to invest in a ferrule crimper. Most Creality boards come with tinned wires that are just pinched into the wire connectors here. That actually is a fire hazard because it can cause shorts and such that will cause sparking, lead to melting, leads to fires. It's not good. These ferrule connectors here just provide a more secure connection into the pinch blocks, which helps reduce the risk of fires compared to those of tinned wires. So next up, I'm just going to remove the SKR Mini E3 board. So now that I have the SKR Mini E3 out, what I'm going to do is I'm going to open up this port here just to make sure it has enough space to fit the USB B style connector into it. I'm basically just going to feed the connector into the board here through this slot, and I have the Raspberry Pi mounted to the Ender 5 Plus frame. This cable will be long enough to reach from the board to the frame where I have the Raspberry Pi mounted, so I won't have to make any additional modifications or reroute the cable any particular way. So I'm going to go ahead and get this machined out, and then I will cut right back. So I went ahead and got the port modified for the USB cable. It's not the cleanest of jobs, but it'll get the job done. It's on the bottom of the printer. You can barely see it, but it's big enough that the USB-B cable will fit through it. Next up, we're going to work on installing the SKR3 board. So I found this adapter. This is an adapter to go from the Creality bolt pattern to the standard 4-corner bolt pattern on the SKR3 board. I will provide a link to this in the description below if you want to follow the same upgrade as me. But it's very straightforward. Pretty much just match up the holes with the Creality post that the motherboard bolts go into. You'll need to add 4 M3 washers to go on top of this to secure it with the bolts. So I'm going to go ahead and get this installed. So I definitely want to point this out because I don't want this to happen to anybody else. But how I was going to route the USB-B cable, and another reason why I don't like these plugs is because they are large and they take up a lot of room. But this is a classic example of measure twice, cut once. How I wanted to run the USB cable here, just to route it in kind of the original hole of the micro USB slot, it's not going to work because the cable is too large and the mounting holes for the bracket won't line up. Now I could go, and it looks like I have enough room to be able to shift this bracket, but I don't feel like reprinting it. It's just easy enough to drill another hole that'll line up here with this USB slot. So that's what I'm going to do. I'm just going to go out back, drill another hole real quick, and be done with it. So now that we have the hole in the correct spot, it definitely works a lot better this way. Next up, you just use some M3x8s to secure the board to the bracket. And then after that, we're just going to plug everything in, reading the labels, putting them in the correct spot. And then once I'm done that, I'll cut back, and then we will actually go into setting up this board for Klipper. One note I want to make real quick is if you're jumping from the stock Creality board, or in my case, the SKR Mini E3 V2, what you're going to have to do is for your hot end fan, you're going to have to switch from either the ferrules like I have or the tinned wires. You're going to actually have to put on a JST connector here, and that is so you can plug in your hot end fan into one of these always on ports. I'm going to be selecting this always on port right here to plug in my hot end fan. So I'm going to go over and switch this to a JST connection real quick, and then I'll be right back. Now that we have the board all wired up, next thing to do is get this enclosure put back into the printer. After that, I'm going to build the firmware for this main board and flash it, the main board. And then after that, I will have the Klipper printer config set up, and that'll be our next steps. So let's go get this back onto the printer. So before we put the electronics enclosure back into the printer, first thing we're going to have to do is build and flash the firmware to the main board, the SKR3. What we're going to use for this is the example config on the Klipper GitHub here, and this will tell us the parameters we need to input in the make menu config menu to build the correct firmware for our main board. So what we're going to do is we're going to open up a putty session and SSH into the Ender 5 Plus. So now that we're logged into the Raspberry Pi, I'm going to use the Klipper installer, updater, and helper add-on. I think that is, or Klipper installer and updater helper. I forget how it goes. So now that we are in the Klipper installer and updater helper, this is just kind of like a quality of life thing. Just makes it a little bit easier for you. You can do it the normal way, just with the going to the Klipper folder and then using the make menu config. I just do it this way because for me it's easier to get it done this way. So what we'll do now is we're going to go to 4, which is advanced, and then we're going to press 2 for build only. This will pull up the Klipper firmware configuration. So we're going to have to enable low-level configuration. For the microcontroller, we're going to go down to STM32. For the processor model, we're going to have to do the STM-H743. For the bootloader offset, we're going to use the 128K bootloader. Clock reference, we're going to move that down to 25 megahertz crystal. And then everything else, we use the same. So we hit Q to quit, yes to build, and it will go through building the firmware. And then we're going to take that firmware file and put it onto an SD card. So next up, we're going to use WinSAP to pull that firmware.bin file over to an SD card. So let's log into WinSAP. All right, so now that we are logged into the WinSAP, we're going to navigate to the Klipper folder. We're going to navigate down to Out, and then we're going to look for this Klipper.bin file. What we are going to do next is we're going to drag this Klipper.bin file over to our SD card. So we'll just drag and drop. Once that is in our SD card, we're going to rename this, slow double click, firmware.bin. All right, now we're going to eject the SD card, and then we're going to flash the firmware onto the main board. So after I flash the firmware onto the main board, I'm going to cut back, and then we're going to go through setting up Klipper once we have everything installed and hooked up onto the printer. So I kind of figured I'd get this next part on camera just in case any of the magic smoke decides to make an appearance. But what we're going to do now is we're going to flash the main board with the micro SD card that we put the firmware.bin file on. The SD card slot you can see is right here down on the bottom. So we're just going to kind of move this aside, move the wires out of the way, and try to get our SD card in there. All right, the SD card is in the slot. This is the first time I'm going to be powering up the printer, so we'll see what happens. Hopefully everything turns out all right. Let's find the power switch, and then here we go. We have power. Everything looks good. We got no magic smoke. We're going to leave this on for a few seconds, and then we're just going to power it down. All right, now that we've powered down the main board and the electronics, we're going to go ahead and install it back into the printer, and I'll cut back after we're done that. So one quick, easy way to tell if the firmware flash was successful for the main board is when you plug the SD card back into the computer, you will see the file name change from a .bin file to a .cur file. If you see this file name change, that means the firmware was flashed successfully to the board, and you should go ahead and proceed with setting up Klipper. That's going to be my next steps, is I'm going to be setting up the printer config. That way we can connect Klipper and Marlin to the main board. So the next thing we're going to do once we have the electronics panel back in the printer and the USB cable connected to the Raspberry Pi that's powered on, is we need to determine which serial port the USB is connected to. They do have a serial port listed in the example config on the Klipper docs page, but we can run this command just to double check, make sure it is the correct serial port. So we are over in the Klipper installation web page. We are going to copy this line over and right click to paste it into PuTTY. And this will be what we need to copy over into our printer config. So we will just highlight this to copy it onto the clipboard. And now we're going to move over to the printer config to set it up. So over here in the printer config file, what we're going to do is we're going to scroll down here to the MCU, and where it says serial, we're going to paste in the new serial ID info. So with our serial ID info pasted in, the rest of this video or rest of this section is pretty much just going to be copying and pasting and changing the relevant information between the SKR2 or the SKR Mini 3 V2 board versus the SKR3 board. I'm going to be using my SKR Mini 3 V2 board's printer config as a pretty much rough template, and all I'm going to be doing is copying over all the SKR3's example config into the relevant sections. So the stepper drivers, what you really need to be focusing on are the step pins, the direction pins, and the enable pins. Those are the main ones you want to copy. Also, you need to focus on the end stop pins as well. Another thing that's going to be different between the two are the heated bed pins, as well as the fan pins, and the display pins as well. So once I get all this stuff copied over, I will cut back, and then we will give it a test run just to see if we can connect and communicate with the printer and everything is working in the right direction. So I'm back with another wardrobe change. This unfortunately took me quite a bit longer than what I was anticipating. I ran into one issue that was more, I guess, operator error than anything. What happened was it was giving me an error of end stop X triggered after retract, I think it's called. I'll emulate the error that I was running into, but I had this error happen before on the SKR-3 board, and it was due to a bad end stop. So that was originally what I thought was wrong. So I ended up swapping the end stop. That didn't fix the issue. Then I thought it was the end stop cable, because I actually have, see if I can find it here. I actually have the cable spliced together with some electrical tape because of a pinch that was in the cable. And after replacing the cable and pulling the electronics bay all the way back out and putting it back in, that didn't fix the issue. So what I'm going to do is I'm going to walk you through the issue real quick of what happened and give you a little idea of how to fix it going forward if you were to run into the same issue. So I'm going to emulate this error really quick and I'll show you what happens. So I'll just go to try to home the X-axis here. And you can see it says end stop X still triggered after retract. What we can do now is we can insert the command, let's see if I can spell it right, Q-U-E-R-Y, end stops. Okay, now what this will do is send signals to the end stops to see if they are triggered or open. And when the command returns, you will see that it says X is triggered, Y is open, and Z is open. So what you can do, and what I did, is I went out and manually triggered the end stop with my finger and then reran the query end stops command. And when that happened, it showed that the X end stop was then open. So if that is to happen, that means your end stop triggers are backwards. So what you can then do is head over to your printer config, and I have my steppers in a separate command. For the end stop pin on the X-axis, it works the same way as the direction pin on the regular stepper motor. So what we do is behind this uppercase caret here, whatever symbol that is, we just put an exclamation point. This reverses the polarity of, not necessarily the polarity, but the direction of the end stop. So we will save and restart, and this will update the printer config for the stepper motor, or the end stop, I should say. So now that our printer config is fixed for the end stop, I will run this query end stops command again, and you can see it returns X open, Y open, and Z open. And now we will go ahead and home the X-axis. And due to internet issues, my Wi-Fi is having issues when I'm trying to record this video, go figure. The X end stop successfully homes, and then we can home the Y end stop, and the Y successfully homes. Now we will try the Z end stop, which is the BL touch probe, and we will see if it successfully homes. It looks like it's successfully homed. So now that we know that our printer can home properly, the next thing up is I would like to try something new, and that is the Z tilt, which levels the bed. And well, for this case, since it's a 2-point level, we have two Z axes, it'll level it in the X direction. So in this section, I'm going to briefly cover setting up Z tilt on the Ender 5 Plus or any printer that has dual Z axis leveling system. So what we're going to do is we're going to come over here to our menu config, and we're going to go to my stepper motors config menu. So now that we're in the stepper motors config, what we are going to do is we are going to duplicate our current Z stepper configuration. So I basically highlight all of this and then hit Shift and Alt and press on the down arrow. That essentially creates a copy of our current Z configuration. So we'll enter this down one spot, and now we're going to relabel this as a separate Z instance. And so all you have to do is put a 1 behind each Z or stepper Z in the config menu. Now, if you were to have a third stepper motor for like tri-axis bed leveling, you would do this again and then put a 2 behind the stepper Z in the configuration. So now that we have our Z instance copied, it's as simple as entering in the new pin values from the pin PDF here. So for the enable pin, we are going to change the PE0 to PD13. So we do PD13. The step pin, we're going to change from PE2 to PD11. And the direction pin, we're going to change from PE3 to PD10. And lastly, the UART pin, we are changing from PE1 to PD12. So we have that copied, everything's in. Now I want to make one thing clear. I made this mistake as well. You do not need to have the position min and the position max or the end stop pin on the second stepper motor. It'll use the reference, well, it will reference the original position min, position max, and end stop pin from the original stepper Z. So we can eliminate that as well. Another issue I ran into is if you forget to label the TMZ 2209 stepper Z, for whatever reason, I don't know the specifics behind this, but it'll actually like turbocharge the second Z motor. So you'll have like one lower exponentially faster than the other, and it throws the bed completely way off doing it that way. So you want to make sure you have these labeled correctly and independently from the original stepper Z. So after we have that set up, all we have to do is save and restart. This should be our configuration for the stepper motors. So after we have the configuration for the stepper motors done, I'm going to go over into my bed leveling config, and we're going to add the Z tilt section. All right, for the Z tilt section, it's pretty straightforward. We just pretty much copy and paste what's on the Klipper configuration page. I'm going to have all my files listed on my GitHub for the SKR3 board, so you can go in there and use them as reference for your printer. But again, these are just reference. You have to make sure everything is set up and working properly. You cannot just copy and paste what I have and throw it into your printer, because my printer is set up possibly different than what you have. But for the Z tilt, you just label the Z tilt positions. For the Z positions, these are the positions of where the stepper motors are as in reference to the bed. So on the first, or when you're looking at the printer, the left side stepper motor is at X0, Y180. So it's in the middle of the bed on the far left side of the printer. The right motor is on the far right side, 360, the whole way to the right, and 180 right in the middle of the bed. The points, these are in reference to where the probe actually probes the bed for the to measure for the Z tilt. So I have it 30 in from the left side, and then I have it 30 in from the right side, or 25 in from the right side. I should make these the same. So we will do 320 here to make them the same. And then the speed, this is the speed of the travel between the 2 points. The horizontal Z move is how far the bed lowers. Retries is how many tries it takes between each side, so it'll measure the left and then the right, and it'll get the tolerance between the two. And then if it's not within, or it'll get the measurement between the two. And if it's not within tolerance, which is 0.02, it'll go back to the left side, take a measurement, go back to the right side, take a measurement. And once it gets within tolerance, that means the bed is Z tilted, I should say. So once we have this section in the bed leveling config, we can just save and restart. All our settings will be applied, and then we can go back to the main menu here. So I'm going to head over to the printer and run a Z-tilt. That way I'm close to the printer and I can just hit the power switch just in case things go awry. As I'm running B-roll for the Z-tilt, I'm going to talk about my final thoughts of this board. I'm going to also give some recommendations on who should upgrade to this board if you're looking to upgrade, and also just my overall thoughts on what I think about the installation, the ease of use, setting up, and things like that. So I'm going to throw up that B-roll and then we'll conclude this video. All right, so as we're watching Z-tilt do its thing, this is one of the big reasons why I'm super excited about this board. This between Z-tilt and bed mesh leveling, pretty much bed leveling is a thing of the past now. You just have to turn your knobs once and then your bed should pretty much stay where it's at as far as being level goes. And then Z-tilt and bed mesh will make up for any discrepancies or differences that might happen as far as heating the bed goes, and warpage from overheating the bed to like 100 degrees for printing ABS and stuff like that. Your board expands and your bed mesh should be able to make up for that difference. So Z-tilt definitely helps for dual Z-axis stepper motors because it allows them to kind of get back in sync for any out of sync issues that may happen when you power off the printer. There's bed drop issues, especially on these larger bed printers like the Ender 5 Plus. It's 350 by 350. That's a lot of weight on powered off stepper motors. So there may be some slight gantry drop, as it's called, when the printer is powered off. So rolling to some B footage of this printer going through, I'm running some test prints just to see how the motherboard performs, and so far I'm really happy with it. Like I said, with the addition of the Z-tilt and the 5 stepper motors, it's pretty much everything I would want in a motherboard right now for the Ender 5 Plus. I have some expansion available with me. I can throw in another constant fan, so I could have a chamber fan going if I need to for exhaust. I also have an extra slot for a PWM fan, so I could throw in, dual 5015s, and I wouldn't have to mess around with having a splitter between the 2 parts cooling fans. Another thing that I like is its native support for Klipper. I'm a big proponent for Klipper ever since I started using it. All my printers run Klipper, and it seems to work really well. I just love the ease of use of it compared to Marlin because you don't really have to flash the firmware. I won't have to reflash the main board every time I have a firmware update or want to make changes to the firmware. It just takes really well to Klipper, and it is, for me, a huge plus that this board was kind of built around using Klipper. Another thing I like is how easy the printer config was to set up. The example config provided in the Klipper example config section was a good head start of what I needed to do just to modify my already existing Klipper config. Again, I will provide links to my SKR3 Klipper config for the Ender 5 Plus in the description below. So if you want to use that as a reference, it'll be available to you in the description below. So just follow the link over to the GitHub and you should be able to get it downloaded. All right, so my final thoughts on this board is I'm really happy with it. Like I can harp on it as much as I can about having the dual Z-axis, but I'm really, really excited about that. I love that. I love having that. I had it on my rat rig, being able to triple Z-tilt adjust, and just having it on the Ender 5 Plus, it's a huge bonus. If there were any things I would change about the board going forward, so like the SKR3, I would get rid of the USB-B connector just because it is big, kind of in the way. If you could move it to a USB-C connector, that would be a huge bonus. That seems to be the universal plug going forward is USB-C, so it would be nice to have that. And also the individual voltage control of the fans. Now, I understand real estate on these small PCBs is limited, and I would have to make some sacrifices in order to accommodate what I'm looking for in the board. For me personally, in my use case, I wouldn't mind giving up that huge Wi-Fi connection. I personally don't need that because I plugged the Raspberry Pi into the board and that's connected to the Wi-Fi. So I don't need to have a Wi-Fi connection on the board. So if I know they have the BigTreeTech Pico, which is, I think is the Pico, that's specifically built for Klipper, but it doesn't have 5-stepper motors, and it doesn't have the voltage control for the fans. So if you could kind of combine those two boards, that would be great. So those are like my only two little issues I could say that I had with the board. But other than that, I'm really happy with it. It's printing fine. It's printing great, actually, with the test prints I've had. Again, I want to thank BigTreeTech for sending this board over for me to review. I wasn't expecting my channel to reach anybody like that, but the fact that I have BigTreeTech products in all my printers, and they reached out to me for a review of the board, I was super excited at this chance and this opportunity, and it was a board I was looking forward to using and trying out the Z-tilt adjust on the Ender 5 Plus. So again, BigTreeTech, thank you for reaching out and sending me this board. So with that, I think that's going to pretty much wrap up this video. I've covered just about everything I wanted to cover with this board. It took me a little longer than I wanted to, and I had to do a few wardrobe changes to get through it, but we made it. As far as videos going forward, I may try and do more reviews. I may review the SKR Mini E3 on the Ender 3s that I have, because I actually kind of enjoyed this, had fun making it, and it gave me a little deep dive into the board and what it was about, and I normally don't do things like that. So if you have any questions or comments about this board, feel free to ask them below. If you have any feedback that you'd want to give me about this review, since it was my first review, I'm not used to doing these style of videos, please feel free to leave the feedback below in the comments section. If you like this content and would like to see more from me, well, you know what to do. If you would like to support this channel and help me grow so I can produce more videos like this in the future, I have links to do so in the description below. And as always, that's enough from me. I'll see you in the next one.